So, if you guys want to please tell me how you did 13.4 number 5, this example of finding an equation of a plane from three messier points.
So find displacement vectors.
Okay, so we threw our 3 points up, and then our displacement vectors were, so between 3, 4, 2 and 0, 2, 1, you got
Negative 3, negative 2, 1.
negative 3, negative 2, 1.
Negative 1.
Negative 1. Okay. And your displacement vector between 3, 4, 2 and negative 2, 1, 0. Negative 5, negative 3, negative 2.
Yeah.
Okay, then what?
Find the determinant.
Okay, so you wrote those into the determinant of I, J, K, and minus 3, minus 2, minus 1, minus 5, minus 3, minus 2.
Yes, sir.
Yes, sir. And then we did what?
Cofactor expansion.
Okay, we found a determinant, right? So we said, okay, this is I times, what was your little matrix for I?
Negative 2, negative 1. And
2,
then
negative 1,
negative 3, negative 2.
negative 3, negative 2.
Minus j.
And your little matrix for J was
Negative 3, negative 1.
negative 3, negative 1,
Negative 5, negative 2.
negative 5, negative 2. And then you did plus K, and your little matrix for K was
Negative 3, negative 2. Negative 5, negative 3.
okay. And then we did the little, what, 6, right?
Yeah. Cross. So.
So we did take these two, subtract those two. So we got, for I,
4 minus 3.
4 minus 3 reads like 1 to me.
Should be.
Okay, then we got plus J's.
Minus
Minus j.
Oh, fine. Minus J.
6 minus 5.
And that looks like 6 minus 5 gives us 1. Plus
I'll give you a hint on what this
K.
is. It's repetitive.
And this guy should be what?
9 minus 10.
9 minus 10 is negative 1. Okay, so what's your vector?
1,
Negative 1.
Okay, so your normal vector
One,
is
negative
1, negative 1, negative 1. Is that the only possible choice?
I got negative 1, 1, 1.
Yeah,
Ah.
that would be.
So where would you get the opposite of this?
Probably if you switch the 2 rows.
Okay, if we switch the order of these two, right? We'll get, instead of right-hand rule this way, we'll get right-hand rule that way.
Oh.
Does it matter?
No.
No, it's still perpendicular to the plane, right?
Yeah.
I'm really not, I don't care about a lot of the properties here. Like, the reason I'm using the cross product here is I only care about that it's perpendicular to both vectors. I couldn't care less how long this silly thing is, and I also couldn't care less which direction it points in, right? So, you get this up to a scalar multiple, right?
Yeah.
And then what do you do with that information?
Use the displacement for a general XYZ.
Okay, so I take a general point, x, y, z, and I think about this green vector that takes me from one of my 3 known points to that.
Yeah.
And so that displacement vector is, in this case where we picked minus 2, 1, 0 as our end.
X plus 2. Y minus 1.
X plus 2, y minus 1, and z.
Yeah.
And then what do I do with the result of the green and the normal vector?
Dot.
Dot them together. So I got 1, negative 1, dotted with x plus 2, y minus 1, and z. And this is supposed to equal
0.
0. Is that 0 a vector or a scalar?
Scalar.
Good on you guys. All right, then what?
Distribute.
Yeah.
Oh, wait, no, dot.
Dot.
Yeah, do the dot product. So you got x plus 2 y plus 1
Minus Z.
minus z equals 0.
Isolate Z.
Okay, this is the equation of a plane, right? Check. What else could you do with this?
Simplify a little bit.
Yeah, you can simplify a little bit, right? I know what 2 plus 1 is. Pretty sure? Still 3? Okay, so I know that x minus y plus 3 is z, right? Is that last step super necessary? Moving the z to the other side?
Maybe at least combine the constants.
It depends. What thing do you want to be a function of the other two, right? Certainly we could move the x to the other side or the y to the other side. That would also be fine. Cool? Good questions, thanks? Do you guys have any errors on this?
So would it be bad if we had like x minus y minus e equals -3?
No, not at all. Yeah, there are lots of alternate forms of this. Any of them are fine. Where are you guys' errors, though? I'm sure you made little flub ups. Where were they?
I did one of the first disposal property drawing.
Yeah.
That was
Yeah,
screwed
so that,
up.
in my experience with students, the mistakes are either that you can't remember how to do this at all, or that when you start, you make some little arithmetic error someplace along the way and it compounds.
Yeah, I added the 2 points of the vectors rather than subtracting.
Yeah.
When you're finding the determinant, I ended up getting 0 for one of them, and so when you do the dot product, I was missing the x. So I had like yz equals 0. I'm like, I just got it. Yeah, it's weird. I guess a line.
Okay, so if one of them had zeroed out, that's actually a reasonable thing. So if one of them had zeroed out, I would get like x is y or something in this like simplest possible case. Is that thing a line or a plane?
You can do the plane, right? Because these unspecified.
Yeah, z is unspecified, right? So it would be the line y equals x in the xy plane. But then z is unspecified, so that'll be a plane.
Okay.
You guys see that? So that does happen,
Okay.
right? And sometimes, like if the z zeroes out, you won't be able to solve for a function of z because that function of z, right, or function, this thing, would fail the vertical line test. You guys see that? So that does happen. It's not disallowed. It's totally fine.